Hello, in this video, we're actually going to see using known Taylor series and known Maclaurin series to evaluate sums of series. One thing I want to add before doing this is that these are known expansions for certain intervals. So we know 1 over 1 minus x equals the series n equals 0 to infinity x to the n for the absolute value of x being less than 1. E to the x equals the series n equals 0 to infinity x to the n over n factorial for all x. Sine and cosine are also for all x. And ln 1 plus x equals negative 1 to the n, x to the n plus 1 over n plus 1 for negative 1 less than x less than or equal to 1. So we have those intervals. And what we can now do is, since we know these functions and series are equal, if we see a series that's in one of these forms with an x value plugged in, we can actually use this series to evaluate. So as an example, we have the series n equals 0 to infinity, negative 1 to the n, x or pi to the 2n, 3 to the 2n, 2n factorial. I'm going to rewrite that of putting all the 2n's together. Be negative 1 to the n over 2n factorial times pi over 3 to the 2n. I'm just taking these 2n's and collected them together. What this looks like is the power series for cosine. Negative 1 to the n, some value to the 2n, 2n factorial. So this equals cosine of pi over 3. Cosine of pi over 3 is a known value that is 1/2. So very quickly, we can evaluate that series. Another example, using a known power series to find the sum of n equals 0 to infinity of negative 7 to the n, 3 to the n. I'm going to do the same thing, gather these n's together. And that gives us the series n equals 0 to infinity of negative 7/3 to the n all over n factorial. Looking at our known series list, that looks like e to the x, some number to the n over n factorial. So this is equal to e to the negative 7/3. So we can use these known power series to evaluate some series if they are matching the correct form.